All right. So we are touching on some conceptual questions from the exercise. Okay. We'll begin with now this first question with set which is there. The first question, complete the following sentence statements, is all something which we've already seen. Yeah. So not much to worry about there. The second question we'll begin with. Okay. Which of the following experiments have equally likely outcomes? Explain. Okay. We're going to go one by one. Okay. The question is asking the outcomes are equally likely or not. Which of these has equally likely outcome or not? Maybe theoretically you have to think, is this equally likely or not? Okay. Or do you think we need a lot of data to decide that? It cannot be decided theoretically. Okay. That's the thought process you have to adopt here. Okay. Now, first sub question. Okay. A driver attempts to start a car. The car starts or does not start. So the car starts or the car does not start. Do you think it is equally likely outcome? Do you think we can use a theoretical approach in this question? You're understanding the question? Anyone who is understanding the question would like to take up the answer? Heyman Ji is saying he's understanding. Okay. Anyone else? Okay. Deepak is saying he's not able to understand. All right. Who else? Dikshit is saying most likely the car will start. That's a good observation, Dikshit. And where are you coming from? What's your thought process when you're saying most likely the car will start, Dikshit? Can we talk about that for a minute?
Sir, this example which they gave, sir, it's not like a coin or any cards example, sir. Because this is about starting, no, sir. And every time we see most likely vehicles, or in this situation, it's car, no, sir. They always start, sir. I think
But we don't even know that particular car is like a bad car or not. Like maybe it does not start all the time, right? But your point is very correct, Dikshit. Okay, like most of the time, car starts, right? In our experience, cars start when we start them. But maybe someone this driver has a particularly bad car, and he's not able to start, or maybe he does not know how to start. Okay. So what is happening here is, so what do you think, Dikshit? Can we use the theoretical approach and say that the car starting or the car not starting are equally likely? What do you think about that?
yes, sir. I have to say that it is equally likely, sir, because
It
we
is
don't know.
equally likely, you're saying, which means car can start also, car can not start also.
Yes, sir. I'm thinking like that now because you said that car might be bad, no, sir.
But the question is whether we can use a theoretical angle in this, and always can we always say that whenever the driver is starting a car, it is equally likely? Can we always say that, Dikshit?
Not always, sir.
Not really, right? Because when we use a theoretical angle, we are assuming that the outcomes are equally likely. And when we are also assuming that it can be applied all the time, whenever a driver attempts this statement, whenever a driver attempts a car, the event that it will start or it will not start are not equally likely, right? We don't know. It depends on a lot of things. It depends on the car, it depends on the driver. In most cases, in our experience, we've seen a car start. So these two experiments are not really equally likely. How many of us are getting what me and Dikshit just spoke about? Can I hear from you in the chat box? What are you feeling about this particular discussion? So here I'm writing not equally likely because of like the points that we discussed, right? Like a car may or may not start, and most cases it starts, and it may just depend on something. Yeah, it depends on the fuel. Yes, Bindu. Abhi, do you understand, Abhi, now how it is different? Even though two things can happen, that you are right. Abhi is saying, so Abhi has a different answer, okay? Abhi is saying we can use the theoretical approach because only two things can happen. It will start or not start. But even though two things can happen, only two things can happen, is it equally likely? Not really, right? Not equally likely, right? Abhi, you're good with this, Abhi? Maybe if we have a lot of data of like thousands of cars, and whenever people have tried to start it, then we can empirically say that, okay, now the probability is we are observing that car for like hundreds or thousands of times someone has started it, and we know that okay, whenever someone tries to start the car, the probability is 0.9% that they will succeed. Okay, maybe if we have data, we can say, but these are not equally likely outcomes. Yeah. Okay. Can I get a fist to five in the chat box about what we just discussed? This is an important concept, guys. Maybe it might not be asked directly in the exam, but I don't want to miss this opportunity in this chapter, and I want us to you know, understand the true meaning of probability, of theoretical probability here. Yeah, that's why this discussion. Right, all right. I am glad to see the numbers in the chat. Abhi, how you are also at 5? Great. Okay, Mansa, great. All right, cool. So now let's read the second question. Okay, have you guys seen the game of basketball? Have you guys seen the game of basketball? You understand?
Yes, yes.
Yeah. Okay. So a player attempts to shoot a basketball. Shoot means try to put it in the ring that is up there. Yeah. A player attempts to shoot a basketball. She or he shoots or misses. Shoots means scores. Okay. Like you kick in football and you score. Shoot is something similar. Okay. He or she shoots or misses the shot. What do you think? Is that equally likely? Are these two equally likely or not? Can I get now for this question? Let's take a minute, okay? Let's all of us think. You can replace basketball player with you can replace it with a football player. Okay, some football player is kicking. Okay, many of you have played football. You are shooting. Do you think it's equally likely that it will be a goal or it will not be a goal? I want you to think about that and then type in the chat box your answer. All of us can type for everyone, okay? Because all of us are thinking on our own. Type in the chat box your answer with your logic, okay? Why do you feel it's equally likely or why do you feel it's not? You have maybe a minute. So what we're doing is we're not just typing it's equally likely, it's not equally likely. We're typing why we think so, okay? What's the reason why we feel that it's equally likely? What's the reason we feel it's not equally likely? Take a minute, ponder over this question, yeah? Some really interesting answers are coming in. Uh, let's wait for at least a few more people to type. I like one or two answers here, like some great answers here. Okay. Will you type for everyone, no? Yeah. All right. Let me start. So there are like a group of answers. Okay. One group of people. That's Deepak, Riza, I think Dikshit now. Many people, like some few others also. I'll just read out Deepak's answer. Sir, I think it again depends on many things. The person who is shooting, the goalkeeper. Riza has also mentioned air, opponent blocks. So all of this affects whether the ball will go into the basket or not. The ball will go into the goal or not. Okay. So Deepak is saying, I think there is not enough data given to make a conclusion. Abhi is saying, no, sir, not equally likely outcome. Abhi also has a point here. He's saying that if the guy who is shooting is a real pro, then he will not miss. Interesting point here, Abhi. Okay. Let's see him. We'll come to him and Gina. He's a different set. He has a different point of view. Let's hear Nishchay. Nishchay is saying it is not equally likely because the number of times the player shoots will not always be equal to number of times the player misses. This, I think, is a wonderful argument, Nishchay, because he's thinking data on the basis of data. Okay, he's thinking if I have to start collecting data. Nishchay, you guys have also played football. Just think if you counted how many times you did a shoot, you made a shot, and how in that how many times you scored, how many times you did not score. There is a very most likely it's not equal. No, that number is not equal. No, like maybe you took a shot some 50 times and scored some 5 times, or if you're really great, you took a shot 50 times, you scored some 25 times. Okay, but it's not sure that that can be equal, which I think is a wonderful way of putting this argument, Nishchay, because you're going back to data. Okay. And Mansa is saying, okay, we'll come to Mansa and Jean a bit. Dikshit is also in this category. Yeah.
Sir, I meant not equally.
All right. Yes, Dinesh is saying whether he's a beginner depends on the quality of the play, on the whether he's a beginner or a pro. Okay. Yes, MG is also saying on this. On like basically there are so many factors affecting it, so we can't really take a theoretical approach. So we have to go to data, and that's what Nishchay's argument is, that if we go to data, mostly it will not be equal, the number of times he scored and not scored. Okay. Let's hear the other side also. Let's just take a moment to hear the other side also. Okay. So Hemanji said, if the player is trained and practiced, there is a high chance in scoring a goal. Yes, there is a high chance, which means there is a low chance of not scoring a goal, no? And also you are assuming that the player is trained and practiced. That's something we don't know. We can't like blanket use a theoretical approach, right, Hemanji?
Yes, sir.
We understand that. Good. I am glad that you brought this up. Okay. Then Mansa, she can hit a shot or miss it, so I think it's equally likely. But Mansa, she can hit. Okay, these are two outcomes. That you are right. Either she will score or miss. But these two outcomes, do you think it will happen the same number of times, Mansa? Like one time she will score and one time she will not score. Like, do you think that is the case? Most likely not, right?
Yes.
Yeah. Yes, Manisha is talking about the goalkeeper also, and yeah. Yes, Abhi, definitely. Not all the time he will goal, sometimes. Okay. So how are we feeling about this question? How are we feeling? So it's not a theoretical situation. We need data to be able to tell the probability of a player, and we need data on that particular player, on that who played in that particular code or in that particular ground with that particular team. So it's all different. Okay. And you know, guys, there's a movie called Moneyball. I don't know if you guys have watched it. Okay, there's a movie called Moneyball. All right, where they tell like, no, I don't think it's Moneyball. Sorry, I think I'm making a mistake. I don't remember the movie, but I learned. It's basically about Moneyball is about baseball. Okay, but what I want to say is like in USA, okay, and even in India now in cricket it has started. Like people, the sports industry people know use probability a lot. Okay, how do they use probability a lot? Like I think it's a Brad Pitt movie only, but it's about basketball. So I'm confused whether it's Moneyball or something else. But you know, like they calculate which player. So different players have played different number of times and in different teams and all. So how to compare players? So they calculate how many times the player took a shot. Okay, attempted a shot. That they calculate as total number of that will be the denominator. How many players? How many times a player attempted a shot, and in that, how many times he scored? So suppose Hemanji is playing basketball, and he took a shot some 50 times in 5 matches. Suppose, okay, and then 50 times he scored some 15 times. Okay, so Hemanji's probability of scoring is 30%, right? So that becomes an important way of deciding which player I want to buy for my team. Okay. Is actually probability is heavily used in the sports industry, even in many other industries, but in sports industry it's used a lot because it shows how good a player you are. What is the chance that when you shoot, you will score? Okay. There are other mathematical factors also which is used, but this is one of the examples, yeah, of which is this is used a lot. Okay, and people so based on this they decide okay there are other mathematical calculations also like how many times you actually took a shot and all of that, but based on all this they decide okay this player I pakka want to buy, so some team will auction, in the auction they will bid more for that player, they will pay that player more money to get that player to the team. Okay, so it's actually working in real life right now. Okay, like it's always working, and this is a sports example, but there are like a lot of other industries in which this is used. Yeah, so can I get a check on how we are feeling about this particular question today? Like how we are feeling about this particular question? Can I get a check? Yeah, we good. All right, all right. Cool. Let's move on to the next one then. Yeah. So the next question is, this is an interesting question. Okay, a trial is made to answer a true false question, which means the answer can be true or false. Okay. Now we don't know the answer, but we are trying. So we are just guessing. Okay, let's write true or let's write false. The answer is right or wrong. What do you think will be uh, the answer here? Okay, take a minute to process this. Okay, take a minute to process this question and then type it in the chat box. What do you think with your logic? Yeah. One minute, Dhruva. Think and type in the chat box. Okay, type for everyone. अगर टेक्स्ट बुक है तुम्हारे पास तो खोल के रखो, ठीक है? Let's read what are the different answers which have come in. Yeah. Yes, the person is wildly guessing. MG, yes, the person is wildly guessing. So, okay, the person does not know. They don't know. They have no idea about the answer. Okay. So Dinesh is saying yes, sir. It's equally likely outcomes. Dinesh would love to hear the reason also in the chat. Mansa is saying, sir, it is true or false question. So the answer should be either true or false. There is no other answer or outcome. So this is equally likely outcome, even if the question is difficult or easy. Even if the person knows the answer or not, I think it's different, Mansa. If the person does not know, till here your argument is correct. Argument seems sound, okay? Yes, the solution can either be correct or wrong. Correct. Since I guess it is equally like a cut. Deepak, I'm not sure I'm understanding what you mean by cut.
Sir, I meant because.
Cause, okay. So I guess it is equally likely because the person, because whatever the person picks, it can be either true or false. Yes, Deepak, that's a sound logic. Okay. MG is saying doubt, sir. Is the person answering the question or no? He's wildly guessing. Yeah, we have addressed that doubt. Abhi said, okay. Abhi, do you feel you are able to understand the question now? Riza is saying, again, it depends on what the question is asked and what is the nature of the person, what is the interest of the person according to the question asked. So, Riza, let's think about it in a minute, okay? We are going with the assumption that the person who has asked this question does not know the answer. Do you get that? Does not know the answer, and they are just guessing. Now, what do you think, Riza? Yeah, that's your assumption. That's a basic assumption you're going with. It does not know the answer. Interest कुछ भी हो, but उसको answer पता नहीं है, और वो guess कर रहा है, तुक्का मार रहा है. Okay. Asghar is saying it is equally likely outcomes because there are only two options, either true or false. Okay. Dikshit is saying it depends on how much the person has studied. Dikshit, again, to clarify that, we are assuming that the person does not know this answer. Okay. Nishchay, again, you're saying it depends on many things, mood of the person, type of the question, but the question clearly says it's a trial, which means the person is taking a shot. All right. Whatever it depends on, okay, we have only two possible outcomes, that is true or false, and one of them is correct. You see, the question can be anything, okay, but if I don't know the answer, like Nishchay has just clarified that also right now in the chat, which is very well mentioned, because I don't know the answer and I'm taking a guess. For me, it's like tossing a coin only, no? Either it will come heads or it will come tails. So I guess heads, I guess true, maybe it is correct, maybe it is not correct. I guess false, maybe it is correct, maybe it's not correct. Basically, these two are only there and both can be correct, both can be not correct. And I don't know anything. So from my point of view, it is equally likely, right? It's a 50% chance that I'm correct. Okay, it's a 50% chance that I'm correct. How are you feeling about this? Because from my point of view, I have no idea about what the question is. Okay, so I'm just going to leave that variable out. I'm not going to care about what the question is causing this, because I don't know what the answer is. Assuming that these two outcomes seem to me like, okay, whatever I choose, I can either be right or I can be wrong. Okay, so like very clearly, because I don't know. Okay, some maybe have a feeling that maybe this is the correct answer, maybe that is the correct answer. That's a different thing. Okay, but I have no feelings here. I have no idea. I have not studied the subject or whatever. I don't know this particular answer. Okay, so that's why this is a theoretical case. Okay, Deepak, in the previous question, how it was different? Let's think about it. Okay, in the previous question, there was data which could be collected, right, Deepak? Like we had an option. Let's see the previous question. Okay, there was a different level of skill involved, like who knows to play, of the ring size, of the ring, of like how far the ring is, of like the air, the opponent who is blocking. So there are so many factors involved. Deepak, I want you to think about it. In question number 3, what factor is involved? It's a true false question. What factor is involved, Deepak? Are you understanding my question?
Sir, is it like that in the football there can be different factors that can answer, but in the answer the following, like true and false, there is only one question, and like you cannot collect more data in one question. But in football there are different factors, so you can collect many data.
That is also a way of thinking about it, Deepak. I'm also thinking, let's stay with this thought. It's a little complicated, but I want to stay with this thought. Mansa, you want to answer Deepak?
No, sir, I have a question.
Okay, hold on. Let me reply to Deepak. Yeah, Deepak, I wanted to think about it like this. Key in question number 3, when I'm making a trial for a true or false question, only 2 things can affect. Basically, one is whether I know the answer or not, and whether what is the question and whether I know the answer or not. Okay, that we have assumed that we don't know. Okay, that we assume that factor is eliminated now. Okay, because we have assumed that the person who is attempting does not know. Now it is just like a coin toss. Okay, because we don't know what we are going to say is correct or false. Okay, because we're just randomly picking true or false. Deepak, does that make sense? I don't know if I'm able to convey properly, like completely well, but how are you feeling? If still not like satisfied about it, can I hear from you, Deepak?
I understood somewhat.
Okay. Let's see if I'm also able to think about it a little bit more deeply and probably able to communicate it better. I have a feeling that my logic is also like not being communicated with very much clarity. Okay, so let me also think about it. But I'll give you actually I can stretch this for some time, but let me think about it and come to you with a briefer and better answer. Okay, Mansa, what's your question?
Sir, I wanted to ask in question 2, sir. Either she can shoot or miss the shot, sir. In the third question, either the answer will be right or wrong. So what is the difference here, sir?
The difference is what's going on in the background, Mansa. Okay, here also, first question also, the car will start or it will not start. All of these have 2 outcomes only. All of these have 2 outcomes. So it is not because it has 2 outcome only. Okay, it is both outcomes are equally likely or not. Okay, both outcomes are equally likely or not. That's the logic we are approaching it with. In the first case, we cannot say whether it will be equally likely or not. In the second case, we cannot say it will be equally likely or not. But in the third case, because the person does not know the answer, we can say that it will be equally likely. In the event the 2 chances are 50 and 50, then it becomes equally likely. Yeah. Now, I feel, Mansa, I am understanding where your doubt is coming from. I feel that my thought process also has some like problem in between. There is like, I am not communicating everything clearly. Like I'm understanding from inside, but I'm not communicating. So I think I'll also work on that. Meanwhile, does anyone else wants to take a question of like, how is this different from these two? It's not just because there are two outcomes, okay? See, every one of these has only two outcomes. But two outcomes, how much chances for both to happen is equal. That is happening only in third one. Maybe if we see, yes, sir. Riza, go ahead. Go ahead,
No,
Riza.
sir. How I thought about this third one is that if I see third one, sir, it can be true or false, no, sir. So even if I say true, my if for the question, if it is correct, it will be 50% chance, sir. If I say
Correct.
false, again 50% chance, sir.
Correct.
So both the outcomes have equal chances, sir. So equally likely, sir. And
Very,
then
very
the
good.
other
Very, very good,
two
Riza.
other two is like the factors is affecting, and you gave example also, no, so if 30% then other will be 80%, so it is not equal percentage of chances, no, sir. So in that way I was thinking.
Very good argument, Riza. Very, very well communicated, Riza. That is one of the reasons, okay? Because here, suppose I put true. What is the chance that it is correct? The chance is 50%. Suppose I put wrong. Suppose I put false. Sorry, suppose I put false. What is the chance that this is correct? What is the chance that false is correct? That is also 50%. Okay, because correct or not correct, there also it's like 50% chance that false is correct, 50% chance that true is correct. Interesting, I like how you put it. But here, suppose car starting is 80%, then car not starting is 20%. Suppose shooting, someone is scoring 5 times out of 50, that well, shooting is 10%, then not shooting is 90%. Okay. But here that's not the case, because the person does not know it's the does not know the answer. The chances are 50-50. Okay. Don't know if it is like completely set still, but you know, how are we feeling? Can I get a fist 5 about this? Maybe you're not at a 5. That's okay. All right. Maybe I am also not at a 5 in the way I'm communicating. But let's hear it in the chat box. How are we feeling? Okay. Okay. All right. Let's see if we are able to understand using the fourth one. Okay. A baby is born. Is it a boy? It is a boy or a girl. Okay. Now there is a like assumption of gender here, okay, that boy and girl, but we are going to think about it physically. You're going to think, is it male or female? Okay, and in most cases it's either of the two, so we are going to not think about the we are assuming that there's only male and female kids born. Okay, so we'll go with that logic. Yeah. Now this is a book which is written quite a long time ago, so they are with those societal, the book is written with that perspective. But let's see. Now a boy is born, a baby is born. Is it a male or female baby? Does anyone know what decides whether a child is male or female? Does anyone know that? What decides whether a child is male or female? Hemanji?
Sir, XX or XY chromosome.
XX or XY, correct. Where is the second chromosome coming from? Where is the second chromosome coming from? Hemanji? Anyone quickly? From the male. Yes, Dilruba. From the male. So the male is sending from the male, what do we call it? Gamete, right? Male sperm is called the gamete, right? Yeah. So now I don't know the exact words and all, okay? But as far as I understand, the female will always send 2 X's, and the male will send, and the male parent will send X and Y. Am I right about this? Okay. So ये X तो distribute हो गया, it went here or it went here. Okay, it can go whether like female say always you will get X. So basically, if I'm getting always X, that is not deciding my child ka gender. What is deciding the second chromosome? The second thing here, chromosome it's called. I don't know what it's called. Okay, but basically this will be X or it will be Y, depending on male ka which one you got. Okay, so if this X came, you will get a female child. If this Y came, you will get a male child. Am I right so far?
Yes, sir.
Am I right? Okay, कहीं कुछ confusion तो बता देना, because I'm not sure that my biology is like very clear on this. But as far as I understand, this is the case. Okay. Now there are also a whole set of people where, and they are big enough that if we take the data, we cannot say it's 50-50 chance. Okay. Like the whole set of people where the chromosome is not XY. Okay. So, but in more than 90% of the cases it is. So we're going to discuss that only for now. Okay. The book goes with that assumption. Now, yes, your next chapter is reproduction. Okay. Now I want you to think about it. Okay. Male gamete will always have the parent male gamete will always send one X and one Y. Okay. Now whether X will come in the child embryo, well, X will come or Y will come. What is the chance? There is one X and there is one Y, and there are only two things. So what is the chance whether X will come? What is the chance of this? What is the chance of this? Can you think about that? It is 50-50, right? It's equal chance. There is no other way out. Okay, so this will have a 50% chance, this will have a 50%. Any sperm, any male gamete, any sperm will always have one X and one Y. Okay, that's the reason. It's like always have one X and one Y. And then when it, depending on during the fusion process, it will either during the fission process, I think it's called fission or fusion. Fusion. Okay, sorry, fission is breaking apart. Okay, fusion, in the fusion process, like it will either give its X chromosome or its Y chromosome, and that's all. So there's a 50-50 chance. Okay, now I want to think about you how are you feeling about this question now? Can I get a fist if I went over this question? Can I get a fist if I about this question? Very simple, very intuitive. Now guys, those who had a problem with the third question, I want to start thinking now about the third question once again. Okay, like the answer is already there, it's true or false, we don't know, but the person is either putting true or putting false. Okay, we don't know, either he can be right or he can be wrong. Okay, that person, the guy or girl can, or the person can be right or the person can be wrong. Yeah. Okay, does this help you also to understand the third question a little bit better? Probably I was able to explain the fourth one better than the third one. I don't think I'm still able to explain the third one better perfectly. Maybe I'll try another time. Yeah. So how are you feeling about this question? How are you feeling about this whole discussion? Like whether we can assume that the outcomes are equally likely or not. What's the feeling? What's the thing there? Can I get a sense in the chat box? You know, guys, even for this, even for the fourth one, there is a way of doing it empirically also. Okay, which is just counting the number of children who are born and seeing how many are male, how many are female. Okay, that's the empirical approach. But if you do that also, the data shows that it's most likely very close to 50-50. Okay, like very close to 50, little bit up and down will be there. That happens when you toss a coin also. Okay, so theoretically, we can assume that these two outcomes are equally likely. Okay, can I get a sense of how you're feeling about how the class has gone so far, and then we'll move on to the other questions. Yeah, I want to check in the chat box quickly. Yeah, how you're feeling about what's going on. Let's continue. Yeah, so now there are a couple of more questions which I want to do, like in the conceptual part. Question 2, question 3, question 2 is done. 3, 4. Okay, question number 3, which of the so question number 3, I want you to like attempt a homework. Okay, it's the question asking, why is tossing a coin considered to be a fair way of deciding whether which team should get the ball at the beginning of the football game? You guys want to take a quick shot? Okay, similar to the previous questions. Okay, you have to think, why is it fair? Why is it fair? Can you answer that in the chat box? Take a minute to think and answer in the chat box. Why is tossing a coin considered to be a fair way? I'll give you guys 30 seconds. Let's hear it in the chat box, everyone. Dikshit, again, we talked about it. It is not enough if there are two possible outcomes. That's not enough. Yes, Deepak is correct that it is equally likely to happen. Okay, they're equally likely. Yes, Dikshit, you added that right now. Perfect. Okay, both two outcomes are there. One team will choose one, and both are equally likely. Okay, coin toss we have seen like unless and until the coin is like manufactured in a way that it will tend to fall on one side more. Otherwise, a coin is usually fair. Okay, so you usually go, so heads ka possibility is also 50% or probability, and tails ka probability is also 50%. Correct. Both are equally likely outcomes. That's why it's a fair way. That's a simple answer. Okay, there's nothing going back. Okay, glad to know that people are getting this. Fourth question: which of the following cannot be the probability of an event? Quickly, which of the following cannot be a probability of an event? B. Why B? Dinesh.
Sir, because probability cannot be negative, sir.
Probability cannot be negative. You are definitely right about that. A can be probability. Does anyone have any other answer? Let's hear from Hemanji. Yes, Hemanji, you're raising your hands.
Sir, probability is between 0 and 1, sir.
Probability is between 0 and 1. That's the actual correct answer. Probability is between 0 and 1 is the better argument than Dinesh said. Cannot be negative is also correct. It's a part of that argument. But can you tell me then why 15% we are accepting? Why are we accepting 15% as an answer? 15 is not between 0 and 1, right? MG?
Sir, it is between 0 and 1 because sir 100 is 1, sir, and 0% is 0, sir. So between that 15% is there, sir. So
perfect, MG. Can someone make this argument even more precise? What is 15 equal to? What is 15 equal to? Yes, Dinesh has written it in the chat box. 15 is equal to 15. 15% is equal to 15 by 100. 15 per century. All right. That's why 15% is an acceptable answer. You following this so far? Okay, I think I have got some really nice answers here. So I'm going to just a minute. I'll just award some questions here. So Dikshit, for that question, I'm giving you like, which you asked before, I'm giving you like 10 points there. And MG, for this answer, I'll give you 5 points. Actually, a lot of people are. Dinesh also, I'll give you 5 points. Yeah. So moving on, we are here now. Next question is what? Which you want to discuss? Question number 12. Let's see. Question number 12. Okay. Actually, question number 12 is not a major conceptual question. Question number 12, we can, guys, question number 12, basically they have given a game of chance. Okay, this is the spinning wheel. Okay, and we are betting. Okay, so suppose Dilruba is betting 2. Suppose Dilruba is betting 2 or so. So someone is spinning the wheel, and if 2 comes, then Dilruba wins. If 3 comes, then Dikshit wins. Something like that. Okay, we're playing that kind of a game. And they're saying ki which of the fall, and they have also said ki all are equally likely. So assume it like this is a fair spinning wheel. Okay, when they say equally likely, it's a random experiment. It's a fair spinning wheel. Okay, what is the probability that it will give an 8, an odd number greater than 2, number less than 9? We all can find this now. How if we confident we can do this question by ourselves? Can you do this question by ourselves? Question number 12. Give me a thumbs up if we can do this question by ourselves. On screen thumbs up is good. Anyone who wants me to do this? Okay, cool with this. Yeah. All right. I just thought just to mention this so that because this exact question, exactly the same question, just like I think the things which are being asked was changed, but the situation was exactly the same. There was a spinning wheel of 1 to 8. This question was asked in the exam, I think a couple of years back in Karnataka exam. So we will just add this to your homework, no? Question number 12. And one other question which I wanted to be discussed was 25. Let's see, 25. So 25, I think there is this part of this discussion has already happened before. You see which of the following arguments are correct and which are not correct. Give reasons for your answer. So you have to basically say true or false. Okay, which of the following arguments are correct or not correct means which of the following sentences are true or false. Give reasons. Okay, the first one is saying 2 coins are tossed simultaneously. Okay, 2 coins are tossed simultaneously. We have seen the sample space yesterday. We have seen that it can be HH, HT, TH, or TT. Okay. They're saying, but they are saying, so you remember we talked about it. They're saying if 2 coins are tossed simultaneously, there are 3 possible outcomes: 2 heads, 2 tails, and or one of each. Therefore, for these outcomes, the probability is all 3. The probability is 1/3. Is this true or false? What do you guys think? Can I get an answer? Yes, go ahead, Riza.
Sir, I think false, sir, because yesterday we discussed there will be 4 total outcomes, sir, if two things are. If two coins
But think of these 3 outcomes are also correct, no? Like it can be either 2 heads, it can be either 2 T's, or it can be 1 head, 1 T, or it can be one of each. That is correct, no? Well, what's
No, but
wrong in this?
if we see the overall the total number of possible outcomes, sir, then it will be 4, no, sir. And
Perfect.
the 2 coins are tossed, the total number of possible outcomes will be 4, sir, but they are directly saying that there are only 3 possible outcomes.
But these 3 outcomes are covering the sample space or not? Riza, can you tell me? The 3 outcomes which they are saying, 2 heads, 2 tails, or one of each. All possible outcomes are covered, no, in that 3. 2 heads, 2 tails, or one of each. Covered, no, Riza?
Yes, sir.
So where is the answer? Where is this argument going wrong? That I want you to check. Read the full statement and tell me. These 3 outcomes are correct. If you see, this is the one outcome. This is the second outcome. 2 heads, 2 tails. The third outcome is this, like either of each, either of one of each. That is correct. Where is this outcome going wrong? Let me come to it. Okay. Now, where it is going wrong is actually not in the first sentence. The outcome is the argument is going wrong in the second sentence. If you see here, they are saying for each of these outcomes, the probability is 1/3. That is where it is going wrong. You want to understand why? Because when I say probability of HH, let's not write it. Let's say probability of 2 heads, it is 1 by how much, Riza? Probability of 2 heads is how much? 1 by?
No head, sir.
Probability of 2 heads is how much?
It will
2.
be 1/2, 1/3, sir, because
Come
both
on,
times.
man. Are these equally, guys? See here, 1, 2, 3, 4 are still the number of possible outcomes. Okay, so my probability of 2 heads is 1/4. My probability of 2 tails is still 1/4, but my probability of one of each is actually 2 outcomes are favorable. This one and this one, and total number of outcomes are 4. So this is 1/2. So this is the sentence where it is going wrong. These 3 outcomes which it talked about. Get these 3 events, you think these 3 events. E1 is 2 heads. E2 is 2 tails. E3 is one of each. Okay. In case of E1, my favorable outcomes is only one. That is this one. In case of E2, my favorable outcome is only one. That is this one. But in case of E3, one of each. Okay. In case of E3, my favorable outcomes are 2. 2/4. Are you getting this? Where the statement is going wrong? Riza, can I get a 55 here?
5, sir.
5, right? We good? How is everyone feeling about this? You see, think about this. Okay, these what they are saying are like events. Okay, and these events actually it covers all events, but they are not equally likely because this event has more likelihood. There's more chance that one of each will come. There is less chance that only heads will come or only tails will come. That's the thing here. Okay, can I get a 55 from everyone in the chat box, guys? Why this argument is not correct? Okay, basically you have to find the probabilities are different. That's all. Okay. Going on to question number 2 of 25. If a die is thrown, there are two possible outcomes, an odd number or an even number. Therefore, the probability of getting an odd number is 1 by 2. Okay, let me explain to you why this argument is not like correct. Okay, now this argument is correct, but there is like a flaw in this argument. I'll tell you. Okay, so the logic is not complete. That's what I think. I think there are two possible outcomes. Yes, two possible outcomes are there, but the probability is 1 by 2 not because there are two possible outcomes. The probability is 1 by 2 because they are equally likely. How they are equally likely? Think about it like this. Or probability is 1 by 2 because we are finding, okay, sample space is 1, 2, 3, 4, 5, 6. My odd number ka favorable is 1, 3 and 5. My even number ka favorable is 2, 4 and 6. Then I am calculating probability of odd number. I am getting 3 favorable out of total 6, 1 by 2. Then I am calculating probability of even number, 3 favorable out of 6, 1 by 2. That's why my probability of getting odd number is 1 by 2. My probability of getting odd number is not 1 by 2 because there are two possible outcomes. Okay, two possible outcomes can still have different probability. I want you to think about the driver starting engine question. Okay, two possible outcomes are only there. Engine will start or it will not start. But it is not necessary that because of that, therefore word, okay, because of that, equal probability we cannot say. Okay, we can say equal probability only when we calculate it. How are we feeling about this? That's why my argument here is wrong. Okay, how are you feeling about this? Can I get a check quickly?
Sir, I didn't understand, sir.
Manisha, okay, there's a little English involved here. Okay, it's a little English heavy thing. Okay, Manisha, you remember whenever we use so when we give a reason, okay, this is the if part is the reason. Okay, this statement is the reason, and then they're saying therefore they're giving this conclusion. Probability of getting is this the reason because why the okay probability of getting odd number is 1 by 2. That is correct. No.
Yes, sir.
The argument is correct. The conclusion is correct. No.
Yes, sir.
But is the reason correct? Reason is true, but is the reason of this answer?
Sir, I'm not understanding the connection between the two statements.
That's what. Okay, Manisha, let me give you an example. Okay. It is like okay, I'm anyone else who can do it, like anyone else feeling like in a better place to do this? Anyone else who got me? G and MG are saying that they got me. Okay, think of it this way, Manisha. I'm trying to think of an example which is closer to you. Okay. If a die is thrown, there are two possible outcomes: an odd number or an even number. Okay. Therefore, the probability of getting an odd number is 1 by 2. Manisha, in the driver example, okay, in the driver question, let's come to this question for a bit. In the driver question, how many possible outcomes were there?
The two possible outcomes.
So can we say that they're equally likely? They're 1 by 2, 1 by 2.
No, sir.
We cannot say no. Two possible outcomes are there here also, no?
Yes, sir.
Okay. Now, Manisha, coming back to this question, what they are saying here, they are saying there are two possible outcomes. Therefore, probability is 1 by 2. Is this correct? Is this logic correct?
No, sir. I think it has to be there are 6 possible outcomes, sir.
No, possible outcomes is, see, Manisha, these are two possible outcomes. No, odd number or even number are the two possible outcomes, right? Can we get something?
Yes.
So it is
Yes,
like
sir.
these three are odd numbers, and these three are even numbers. That is covering all the possible outcomes. There it is correct. That part is correct. But that is not the reason that it is 1 by 2.
Okay, sir.
You're understanding the difference here?
Yes, sir. I understand.
Okay. I don't know if I was able to explain it like completely, like properly. Okay. Just wanted to spend, like, this was, I feel, a good discussion. Maybe has gotten us thinking, and maybe it has also gotten us in an exercise of like how to make our argument sharper, or how to find the flaw in the other person's argument. Because you guys have found flaw in, like, my argument was not consistent or perfect in a couple of situations in this class, and you guys have been able to catch that brilliantly. Because when I am feeling that maybe I'm missing some logic here, you are also catching it brilliantly. Okay, and that's amazing. Okay, I love the way this class's discussion has gone. So what is, though, Nishchay is asking a good question. What is the reason for it to be 1 by 2? Nishchay, reason for it to be 1 by 2 is the calculation that we have done. Probability of odd number, it has 3 favorable outcomes out of 6 favorable out of 6 total outcomes. You getting me, Nishchay? That's the reason, because both of them have equal number of favorable outcomes. Correct, Nishchay? Both of them have 3 favorable outcomes. That is the reason that it is, probability is 1 by 2. Okay, both of them 3 out of 6. That's the reason. Getting it, Nishchay?
Yes, sir.
Yeah. All right, guys, it's okay if you're not like at a 5. That's okay. But I want an honest check on like how you're feeling about this discussion. Testify in the chat box quickly. Testify in the chat box quickly.